Today we're going to look at our second form of a quadratic equation. So yesterday we looked at how to graph in standard form. Today we're going to look at how to graph in something that is called vertex form. Yesterday I gave you a heads up that I think, in my opinion, and I think pretty much all students would agree with me, that standard form is the most work intensive to be able to find the vertex and plot out the points that way. So it's nice that today's will be a little bit easier. And one of the reasons why it's called vertex form is because the vertex is readily obvious from the original equation. So yesterday most of our work was in finding the vertex, doing the negative b over 2a and then plugging that in. Today in vertex form, our vertex is going to be right there in our equation for us. So yesterday we looked at the standard form, ax squared plus bx plus c. Today we're going to look at vertex form. And in vertex form, our equation is going to look a little bit different. This is our equation in vertex form. It still has an a value, and that a value is still going to determine whether our graph is facing up or down and is wide or narrow. So we can still use that a value as a check for us when we're done with our graph, making sure that it's facing the right way, up or down, and that it should be, relatively wide or narrow, depending on how big that a value is. But instead of just everything being listed out and added together, we have this parentheses squared that's happening. The vertex is going to be the opposite of the number that's with the x, and then comma the number that's with the k. Remember when we talked about how our graphs shift sideways when we looked at those absolute value graphs? We said that whatever was inside with the x was a side-to-side movement, but backwards. That's what's happening here too. That's what is with the x is going to move our vertex side to side, but it's going to go backwards. So our vertex is going to be at the opposite of what's with the x, comma, the k value, whatever's at the end. So step one is to find that vertex. Opposite of inside, comma, outside. So our vertex in this first example is 1, 3. So yesterday the majority of our work came in finding that vertex. Today our vertex is just there.
Wait, how did you find it?
The opposite of the inside value, comma, the number that's added at the end.
Oh, so if it was 1, it would be negative 1?
Yes. Yep. So if you have an adding inside, it would be a negative value for the vertex. And then we're going to find a second point by plugging in anything we want. Once again, we can plug in 0. If you plug in 0 and you get something crazy, you can just plug in whatever's right next to the vertex. Some students just do that right from the get-go instead of always plugging in 0. Yesterday, plugging in 0 was a really nice and easy thing to do because it just always gave us that c value. Today, it is not necessarily any easier to plug in 0 than anything else. So you could plug in 0 if you want, or you could just plug in whatever's right next to your vertex, which in this case would still be either 0 or 2. But that'll keep your numbers more manageable. The further away what you're plugging in is from your vertex, you might start getting kind of crazy numbers to try to graph. So if you stay close to your vertex, that'll give you a more manageable number to graph. So if I plug in a 0, I get 2 times 0 minus 1 squared plus 3. Once again, you can feel free to use your calculator to do your arithmetic if you want. And I get an answer of 5 here. Remember, if you use your calculator, that parentheses are really important.
So you just plug in 0 there?
Yep. You can pick whatever number you want and plug it in. You can plug in 0 every time if you want, or you can plug in whatever's right next to your vertex. And that'll work too. So since my vertex was at 1, you can plug in 0 or 2. You can really plug in anything. Those are just probably the things that people would choose most often is either 0 or right next to the vertex. They're still parabolas, so they're still going to have a symmetry. So we'll use symmetry to find our third point. So I'll get myself some graph paper up here so we can plot this out. So my first point was my vertex, which is at 1, 3. And yesterday we learned that through that vertex, we can draw in a symmetry line that's going to act like a mirror or a line to fold our paper along. And whatever happens on one side has to happen on the other side. The second point I found by picking 0 and plugging it in and getting 5. And I can fold that over to the other side of the line and connect the dots to get my parabola.
Can you go to that second point again?
Yep, so I plot the vertex, and then I plotted my second point at 0, 5, and then the third point comes from taking that point at 0, 5 and reflecting it over that mirror line. So I just take that point and make it match exactly on the other side. I always start to think they look like a dog, or when we do this lesson a little bit closer to Christmas, I start to like see Rudolph on there. Something too. And you got little antlers if you draw the arrows on the ends, right? Yeah.
Doesn't
So.
it look like
All right.
Maybe a luggage.
Questions?
Thank you.
They're so cute.
Thanks. My socks.
All right. Second example.
One's taller than the
First
other
step.
one. I just
Find the
couldn't
vertex. The vertex is at the opposite of the inside, comma, the outside. So this time's going to be at -3, 4. Opposite of inside, comma, outside. Then you can pick anything you want and plug it in to get your second point. So I could pick 0, and if I plug in 0, I get -1/2, 0 plus 3 squared plus 4. Which is going to be -4.5 plus 4, or -0.5. That is not unmanageable to plot, right? So that's not a big deal. So that one would work fine. Or another option is to always plug in something that's right next to your vertex. So another choice to plug in is I could plug in a -2. And if I plugged in a -2, drawing random lines here, -1/2, -2 plus 3 squared plus 4, I get 3.5. Okay, you don't have to do both of those, I'm just showing you some different options. You can plug in 0 every time if you want, but sometimes your numbers might become kind of unmanageable to plot, really large or really, really small, where you'd have to start scaling by something else. If you plug in something that's right next to your vertex, your numbers are going to stay closer together. So when I plot these out, my vertex is at -3, +4, and I get my symmetry line through there. I can plot the point at 0, -1/2. And I can fold that over. That's 3 boxes away from the dotted line, so I want to go 3 boxes away out on the other side to get its matching point. So that that's perfectly mirrored on one side and the other. Or if instead you had plugged in the -2, our second point would be at 3.5. And I can mirror that point over. Either way, connect your dots to get our curve. Once again, you can kind of verify that your curve is at least turning out looking somewhat right. It doesn't guarantee everything's right about it, but you can guarantee that it's at least looking kind of right by looking at that A value and saying I have a -1/2. That means our graph should be facing downward and be a little bit wide, okay? As opposed to a bigger A value would make it more narrow. So that can kind of help you confirm at least the up and down thing. That if you know your graph is supposed to be facing downward and it's facing upward, you know you've got a problem. So then you need to work back through your arithmetic and figure out where that problem is. Okay. Questions? Alright, so step 1 is find the vertex. Vertex is at opposite of the inside, comma, the outside. Step 2 is find another point. Pick an x, so you can pick 0 if you want. If I pick 0, I get -23. It's a little bit unmanageable to plot. I mean, you can start counting by something else if you really wanted to do that, and that's totally fine. But I'd rather not rescale my graph unless I really have to. So another option is to pick something close to your vertex. So like I could pick 6 because 6 is right next to 5. If I plug in 6, I get 1. That's a little bit more manageable to plot.
So you can like substitute. You can plug anything in, so instead
Yeah.
of 0 you use 6.
Yep, you can plug in anything you want. So you can plug in 0 every time, but sometimes your numbers might get crazy. Or you can just stay right next to your vertex and then your numbers will stay smaller. But I mean, you can plug in 3 if you wanted. You can plug in 10 if you wanted. You can really plug in anything you want. But the closer you stay to your vertex, kind of the more compact your graph is going to be for plotting your points. So I'll plot the vertex first at 5, 2, and I get my line of symmetry there. I'm not going to plot 0, negative 23, but I will plot 6, 1. And I'll fold that over the mirror line. And then connect the dots. And it's facing downward, which is what we would expect since there's a negative in front of the equation. Okay? Questions? All right, your homework is still from section 5.1. So we were in section 5.1 yesterday. We're back in section 5.1 again today. You don't have any from 5.7. For some reason, the textbook only does inequalities in standard form. I don't really know why, but so we're not going to go back to section 7 again where we did the inequalities. But we will still be in section 1. Make sure that you do notice that you got some problems at the beginning here that you need to graph. And then it says again, like yesterday, you don't need to label your vertex and axis of symmetry. They'll be in your graph, but you don't specifically have to write them or anything. But do also notice that there's problem 52 at the end of it as well. Don't miss that one, please. Okay?